Hey Algebra 2 students, welcome to our day 5 on probability. We're going to be looking at probability calculated with tables as well as with trees. So kind of, has a little bit of alliteration there. Now before we do, we're going to do a little bit of warm-up of the basic probability that we saw in the last video with replacement and not replacement. Those are those big vocab words we talked about. And before we even do that, we've got our math meme of the day. So you may recognize the meme on the left over here. That's one of those famous quotes from the Hunger Games book series as well as movie series. And the quote is redone over there on the right to make it a little bit more in terms of probability vocabulary. So instead of may the odds be ever in your favor, may the probability be ever be in your certainty. It doesn't really roll off the tongue, does it? So let's do some practice. Today's warm-up, this is the concept we learned yesterday. And the big things that you'll see, and I think there's actually a third question there. There we go. The vocab words that you're going to see is, let's see. Like number 2, without replacing the first, right? Without replacing the first. Replace it in the bag, right? So this first one is a little bit different than the other because you are putting it back. The other ones you are not putting it back into the bag. So this is a good test of how well do you remember the topic from the last video. So go ahead and pause, work out the problem, and unpause when you're ready. Okay, here are your answers. As we're looking through these, notice the first one, you are replacing or putting that first marble you choose back into the bag. And that's why when you do your second marble choice, notice your second fraction is also out of 5 because you put the marble back, so there are still 5 total marbles. And there are also still those 2 turquoise marbles because you put the one back into the bag. And notice how that compares to part B as well as part C. Part B is the same concept except for you're not putting the first marble back into the bag. So your total goes from 5 to 4. Your total turquoise goes from 2 to 1 because there's one less for each of those totals. And then notice I did have to simplify my fraction for part B and C. You want to make sure you double check that. Part C is a little bit less obvious because notice the 5 turns into 4, but that is the 3 magenta and the 2 turquoise. So it's like a little bit different. It's not necessarily going down by 1, just like part B. It's just you have 2 different totals that you're dealing with. Okay, so make sure you feel good about those. Those are some pretty standard replacement versus not replacement. And then we're going to move on to our new topic. And it's not really so much as a new idea. It's just looking at probability in different forms. So rather than describing a situation, we are going to be looking at some table information and figure out probabilities based on the data. And this is a little bit more like how you might see probability in real life. So this first one is table probabilities, and we have some information about lattes and frappuccinos, espressos, coffee, and we have different sizes here, types here. And notice the last bit here, if you look as totals, right? So what that means is if I go vertically, here are all my coffee orders, right? 65 were tall, 125 grande, 100 venti. So 290 of the coffee, or 290 total coffee orders. And then if you look at the 700 here, that's taking all the coffees, all the espressos, the frappuccinos, the lattes, and adding them all together to get 770. However, you could also add it a different way if we go about it adding together total talls. Notice your total talls is your tall lattes, your tall frappuccinos, your tall espressos, your tall coffees. All of them combined would be 290. Total grandes, total ventis, and then that gets you to 270. So you can think about adding based on type of drink or type of cup is kind of how this table works. And if this stuff is interesting, the AP stats classes do work, with stuff like this, looking at how to organize data sets, right? So this kind of stuff might be interesting. If it's interesting, you might like stats, is what I'm getting at. So the first one is, what is the probability that if I just pick some random coffee, it will be a grande? And notice this is, of course, the orders taken at the Starbucks on Dodge in a single day. I have a feeling it's a little bit lower than that right now. So let's see, what's the probability if I pick any coffee order, it's a grande? Well, how many grandes? We want total grandes, right, over total orders. So how many were grandes? Let's see. Grande total was 305. What's the total? Your total of everything is 770. What I'm going to be doing is I'm going to pull up my calculator, so I'm going to pause the video real quick. And something like this, it's a little bit less obvious if your fraction simplifies, so I'm going to type it in. And then I'm going to do math, enter for fraction. And it does simplify to 61 out of 154. Okay. You want to make sure you leave both options though, because the last one is fully simplified, but the first one really connects to your data set and you can see exactly where those numbers came from. So you want to keep both of them. What is the probability I choose something that is both a grande and a coffee? So where is the grande coffee? Treat it kind of like a multiplication table, right? Grandes are this, right? Coffee is this. So the grande coffee is 125. So we want total grande coffees over total, right? I'll put it as total orders. So our grande coffees are 125, our totals are 770, and let's double check to make sure that that doesn't simplify at all. Looks like it's 25 out of 154. It's kind of interesting. Both of those have denominators of 154 so far. Okay. The next one, C and D, are a little bit tricky, but not too bad once you kind of understand there's like a small little trick to them. So I have one that we're going to do together, and then you guys will do part D as a quick practice problem just to see how you feel. So part C asks us, what is the probability I choose a grande or I choose coffee? So we want all the grandes plus the coffees over your total orders. You can kind of think about this like, remember when we did some basic probability at the beginning and we looked at like picking Halloween candy. If I want the probability, I could choose a Snickers or a Milky Way, right? Adding all the Snickers and all the Milky Way together. So I would say, okay, so grandes, my total grandes is 305. And that's okay, my coffees is 290. And I would say, okay, my total orders is 770. Now there's one issue there. If you guys notice, and I tried to pick my colors strategically, do you guys see how right over here, those totals count 125 once for the yellow and twice for the blue, which makes it green. So it's actually being double counted. So the one caveat here is we have to do at the top minus 125 because we counted twice. It's just like, remember, if we go back, I believe we had a problem. Yeah, this one here, like the fall versus spring play. Anytime you've got overlaps, if you kind of think back to that problem, there's an overlap issue. So you could have like all of your grandes, right? All those are counted. Here are all of your coffees. And then there's that small spot in the middle there where we're going to be counting this zone right here 2 times. And that's why it got shaded over. So that's why we have to take away one of the overlaps. Okay. So that's the spot where you're both a grande and a coffee. So you have to take it away because it was counted too many times. So let's see, we have 305 plus 290. We're going to take away 125. So it's going to be, I'm going to write down here, 470 over 770. It's kind of a nice fraction. Now let's do math frac. It's going to be 47 over 77. You probably could have guessed that, right? Canceling out the 2 zeros. Okay, so now you guys have part D, and it's really similar to part C, and you're going to do that for practice, seeing what's the probability you choose an espresso or a venti. Okay, so pause the video, work through, unpause when you're ready to check over. Okay, so here's your answer for part D. This one is a little bit entertaining because if you look at your espressos and your ventis, there's actually no espressos that are a venti size. So when you subtract the overlap where you have both, it's actually a 0 in this case. If I had said espressos and grandes, you would have subtracted a 5, right? That would have been your overlap there. Or talls, you would have had 25 that got counted 2 times. So this one was kind of an interesting trick. Notice I simplified my fraction using MathFrac there. You want to make sure you do that at the end. Okay. And this last one has a symbol, and you'll see this as you continue in math. What that means, if I read it phonetically in words, it's asking me what is the probability that you have a grande size given that you're only considering the coffees. So what that means is I'm only considering coffees. I'm going to just switch my highlighter just so I can leave the old highlights there that we were discussing. And I'm just going to erase this just so we have that old idea there to look back at. So if I'm only considering coffees, my coffees are over here, right? It's this column here. So what I would want to do is I would say, okay, probability of grande given coffee is equal to, I'm only looking at coffees. So coffees is my new total. I'm not considering everything. I'm just saying, okay, if I only think about coffee, what's the chance that I choose a grande? And then at the top would be your grande coffee. So what are my grande coffees? There are 125 grande coffees, and my total coffees is 290. So this is called conditional probability. It's just the idea that I'm adding an extra condition, and I'm saying, okay, I'm restricting the total. I'm only going to really look at the coffees. I don't care about any of the other drinks. So it's just an idea that we change the total given a condition. So we give condition, and it changes total. So let's just double check that that doesn't simplify. 125 over 290. Right, both of those are divisible by 5 because they end in a 5 or a 0. So it should simplify a little bit. 25 over 58. It's a little messy. I'm just going to fix that up. Okay. So there's our probability that if I'm only considering coffees, I'm going to choose a grande size. Okay, so that's the end of our table problem, so pretty quick. Our next idea is called the tree problem, and you probably guessed it that it doesn't involve anything like maple trees or pine trees. It's just the idea that we're going to go back to tree diagrams like we did at the beginning of the unit. And this is a very typical type of problem. You see these a lot in textbooks. It's always about parts being created in a factory or medical tests being done. So this is a pretty standard looking problem. Again, if these kinds of problems are interesting, you might want to consider stats in the future. Stats would be a good course. So we'll probably start this and then finish it in the next video because I'm a little short on time. So suppose that 5 out of 1,000 people in the United States are cocaine users. This is typically about the time that I get a couple Snickers in the back of the class. Just trying to make it a little bit more normal. So let's kind of make a tree diagram. We have cocaine users, there are 5, and then, oops, sorry about that, non-users. Out of the 1,000, there's going to be 995 people left who are not users. And then once we've kind of got that first divide, suppose that there's a test. It's just like a drug test. Suppose that the test is 97% of the time accurate when given to someone who uses cocaine. So that means if I'm in the cocaine branch over here, if I take the test, right, what's going to happen is I'm just going to put the percentages. That's terrifying. Oh, guys, I'm having some technology troubles here. So that basically means if I take 97%, that's going to give a positive rating. And then the other 3% is a negative rating. And it looks like I'm going to have to refinish this in the next video. Okay, so go ahead to video 2.